Mathematics Education Seminar. Very happy for you to be here. I'm happy to be here myself. I'm Rogier Bos, and together with Anna Schwartz, we're co-organizing these meetings that will take place every month on Thursday, is the plan, the third Thursday of the month. And we're intending to have speakers on a range of subjects, all within mathematics education. There are, fortunately, because this was our intention, there are people here from several institutions across the Netherlands. We have visitors from Nijmegen, from Hogeschool Windesheim, but I'm not sure. Almere, there you go. We have someone from the, we have people here from the Hogeschool Utrecht, and from Leiden, and,
Amsterdam.
From Amsterdam also. So we're very happy with that, because there's of course the yearly meeting where education meets research, where most of you I've seen, I think, on that occasion, but we don't have meetings where research meets research, and I hope that these monthly meetings will meet that gap, fill that gap. I won't talk much more. I will just invite you at some point. I will send this form through the room, and you could fill in your name and your email if you'd like to stay up to date about our meetings. We have a website that you could go to, which is on the Freudenthal Institute page under research, and then research seminars. There you can find information, but through these emails we'll just send you one email announcing every new talk. All right? Did I say it all?
Almost, and if you feel yourself or will become feeling yourself during the presentation, like presenting one of the next times, please reach us. We are very welcoming all your initiative, and we'll try to find a place, since we hope to run for some time. And I'm very pleased to introduce Lonneke Bolles, who took courage to be the first. And she will be presenting on the results of her eye tracking studies and how do they inform further design projects for enhancing statistics learning. Welcome.
Yeah, thank you very much. Hi everybody, and welcome at this presentation. What she didn't tell you, I'm a researcher at the Freudenthal Institute, doing my PhD on a scholarship grant from the NWO, but I'm also a secondary school teacher. A few months ago, a colleague of mine got the diagnosis of pancreatic cancer. And I don't know if you know about this disease, but usually you have like 2 to 4 months to live. But he was very lucky because he had a doctor that was very eager at finding new treatments. And there was this randomized controlled trial, it just finished, and she phoned the researchers and got the results. Always the details. But these are very disappointing because the mean survival time after the treatment is exactly the same as in the control group, and also there's variation in the data given by the black thing up there. It's the same. But these researchers are very smart. So they called in a statistician and asked the statistician for help. And the statistician said, well, let's make histograms of the data. So they did. And as you can clearly see, the doctor says, there are many, like 4 people here who have, who are supported by the treatment, by the control in the control group, and only 3 in the treatment group are profiting from this disease. And now Paul looks very worried because he thinks, what she's talking about? This is totally wrong. Yes, it is. This is one of the major misinterpretations people have when they look at histograms. It's not one bar, one case. A bar stands for several people, several cases. So what you actually see here is that in the treatment group there is a clear split. There is one group that profits almost not from the treatment, and the other group clearly profits from the treatment. So this enables further research for personalizing medicines. And it's not only this doctor that doesn't understand histogram. It's also other researchers, mathematicians, mathematics teachers, and the students in my classroom. And we have invented a lot of interventions to help the students to better understand histograms. So instead of like 20 or 30% of the students who understand histograms, the numbers go up. And we get spectacular results, like 50% of the students understand histograms. But for me as a teacher, that is not a result that I like very much, because it still means that half of my classroom doesn't understand it. That's not what I want. So I will tell you in this talk more about what we can do, what we think we can do about that. But before I can introduce what we found in the literature, I first need you to talk through the key concepts that students find very hard, and that are two statistical concepts, data and distribution. And to clarify what I mean by that, I use these two graphs. Here on the horizontal scale, you see the names of babies, and on the vertical scale, their birth weight when they were born in a hospital in Queensland. In this case value plot, you can clearly see the variation in the birth weight. In this histogram, I also depict the birth weights of these babies. But I've thrown away one variable, the baby names, because that's not relevant for us. But if you look at the mean, and if you look at the variability, the variation in the graph, they are totally the same, because it's the same data underlying both graphs. So in terms of the key concept distribution, they are the same. Whereas if we go to the key concept of distribution in another type of graph, these graphs look quite similar. But the data underlying these graphs are totally different. Because in the left-hand graph, a case value plot, we only have 9 cases of students collecting garbage on the beach with a weight scale over there. And if you want to look at the mean weight that is collected, you can think of a horizontal line. The line that makes all bars equal, you could say. Whereas in the right-hand graph, we have 66 parcels of a postman who delivers those parcels, and the mean weight can be depicted as a vertical line that you have to put on the spot where the graph is in balance. So the variation and the mean in the graph is totally different, and so are the data that are depicted in this graph. But the outside features like shape, color, number of bars, and even the weight scales are the same. So we thought that maybe this is one of the reasons why this problem with histograms is so persistent, that despite 30 years of research and interventions, we still have like half of the students not understanding histograms. And not only that, sometimes after an intervention, students know less about histograms. So it gets even worse. So we designed an eye tracking study to dig deeper, to dive deeper into what is going on here. And we had like 6 histograms and 6 case value plots, like the two ones I showed you before, but without, of course, the lines for the mean. 3 single histograms, 3 double histograms, and the same for the case value plot. So that was our, you could say, neat experiment. But we also want to get a knowledge about what kind of task could we give students to support their learning. So after these 12 plots, we had 6 messy dot plots, 3 histograms to find out if these messy plots did their work, support learning, and then 2 stacked dot plots, because people say that stacked dot plots are better or support students more than the messy ones. And other people suggested that horizontal histograms are more natural because then you can find the mean in a kind of similar way as in the case value plot, namely this horizontal line. So, well, now you know all about data and distribution, and I will show you some results for the eye tracking study, but first I have to tell you that we had 50 secondary school students of one Dutch school, grade 10 to 12. Age was 15 to 18 years old, and there was one person of 90 years old. The setup was 50 minutes, it's one lesson, in which we had a pre-test of prior knowledge, a questionnaire on possible relevant covariates, the math grade, CETA score, and so on. We collected eye tracking data of all these participants on those 25 items or questions. And that took only like 8 to 15 minutes, with some outliers from students that had needed like 26 minutes. And after that, half of the students, the first half, the 25 students, we gave them their eye tracking data back, and we had a cute retrospective interview with them while they were looking at their own eye tracking data. So we are going to look to that data as well, but before I show you the video of the data, I will show you what you can see in the data. So we have this question that was posed: what is approximately the mean weight that is collected per person? In the graph is the weight collected garbage of a beach, Terschelling in this case, the weight scale, and the names of the participants, the students. And this is item 4. And during the gaze pattern, this is what happens. The students goes from left to right with a horizontal gaze to find an estimation of the mean. But this student applies a similar pattern on the histogram. First, he or she looks at the shape, and then you see this horizontal pattern as well. Whereas in a histogram, what you need, or what we expect, is a vertical pattern. So on the video, it looked like this. So this is the screen before. And now the student starts reading the question, rereading the question, reading the graph title, looking at the shape, and here you see this horizontal movement, and then the student checks the answer because it landed on the weight scale, check the frequency, and then still sticks to the answer 10. And if we look back, 10 is here on the weight scale. It's impossible as a mean. So I'll show you again, because I know that if you're not familiar with this, it's hard to see it immediately. So here's the reading. Reading again, and then the shape, the horizontal movement, and now it's the checking procedure, frequency, before the eyes already landed on the weight. And then you see around 10 there was a fixation, and back. And fixation means that the student looks longer. So the red spots are the places where a student looked longer. So to summarize the cases of this student, in a case value plot we see this, what we call a case value plot interpretation strategy. And in the histogram, we see the same strategy applied. So we have a correct and an incorrect strategy.
But do you know about the pre-knowledge of this particular case that you just showed the students?
Not from this particular case, but they have had a lot of graphs, including histograms, in grade 9 already. So, and the grade 11, 12 students rehearsed it in grade 10 and 11. Yeah.
So this really just confirms this persistent.
Yeah. Yeah. And not only, actually, because I also did it with 20 teachers. It's not only the students, it's also with teachers that some of them have the same persistent misunderstanding. Yeah, misinterpretation. So let's see where I am. Yeah. So I think from these data, it's quite clear that we need more attention for the key concept, data and distribution. And if you look at the literature, there's a lot of attention for this key concept distribution, but there wasn't that much attention yet for the key concept data or big idea. But maybe you're wondering right now, why should we learn them histograms then? If that's so hard, can't we do without them? And our answer is clearly no, you can't. Because first of all, as we've seen at the pancreatic cancer example, different graphs reveal different aspects of the data. That's one reason. The other one is histograms are omnipresent in research and education, so we can't learn them, not learn them to students. And more important, the alternatives entail some of the same problems as the histograms. For example, if we take the dot plots, the height misinterpretation that students have is also there for some students. And if we look at another univariate graph, it's like a box plot, we have a even more advanced way of reducing the data, reducing the information. And we think it's not the graph itself that is the problem, it's the key concept that is underlying this graph and underlying these difficulties that is the thing that students don't understand. So I will now tell you something about the findings from the previous studies that we used to design our tasks. And one of it is that if we compare this case value plot with a histogram, there are actually some steps in between. You can transform the case value plot into a histogram in intermediate steps. And some of these steps might clarify for students what is going on. So I'll talk you through that. So we have the same baby girls that were born in Queensland, 26 on one day. And we take the top of the bars only. So we get these dots. And note that we don't have the second axis anymore. So now we have one axis only and only one statistical variable, weight. We slit the dots to the left and get what I call a vertical dot plot. Then we have to rotate it and mirror it because it is like that. And we get the messy dot plot that some of you might be familiar with. And before we get to the histogram, we first have to make bins. So we make bins with roughly the cases positions at each measured value. And this is what I call a histodot. And that is very important because a lot of students and even some of the teachers think that in a histogram, all cases have the same value. The middle value of the bar or the left border of the bar or the right border of the bar, or they say it's confusing because there is not a clear number if you give both borders. So what is the value for the cases in this bar. But there is not one value. So from here to here, you throw away information. And this is not clear for a lot of people. And note that in both cases, I don't need the vertical axis because I can count how many cases there are in a bar. It's only when we come to the histogram that we need the reappearance of this vertical frequency axis, making people think that we have two statistical variables here instead of one. But that's not the case. We have only one statistical variable, the one on the horizontal. And the other one is just to facilitate our understanding. And if you think this is very interesting, I want it in my lecture as well. Thanks to a colleague of us, Kees van Eyde, he programmed all these plots in R, and he's now putting them in a program, Shiny Apps. So this will soon be available for you to use it in your lecture, not only with the birth weight data, but also with your own data. You can upload them and then it will work. So another finding from the literature. In some school books, or actually I should say in many school books, this is a representation of a histogram. But maybe after my talk, you might now understand why I say I don't know what it is. It can be a case value plot, it can be a histogram. Or should I know it because the bars are closed? No, there are many people making histograms with the bars a little bit separated for several reasons. So this is not a good school book item, nor a research item. And some researchers use this kind of histograms in their research. Another thing we learned is that some contexts are very hard for students. For example, this one with the weekly pocket money, where you have euros per week on a horizontal scale. And several students think that this is a time scale, so that this appears later in time than that one. So it's not a very good one to use in our task. Another one is that students think that height is always in that direction. But this is an interesting one. We didn't skip it. We use it to create a conflict in our task because we want to get awareness of students that the relevant variable is here, the statistical variable is here. So we use a height context in which that is obvious. Another thing is from this eye tracking study, well, we learned actually several things, so I have to look up what I wanted to say here exactly. Oh yeah, we found a new misinterpretation that it's not only that they misinterpret the measurement level of the variables, or that they think that the relevant variable is on the vertical instead of on the horizontal. So they confuse how many statistical variables there are in the graph. But it's also the orientation of the variable. So that's a finding that we add to the findings that we had before. And it's all about data. But there is another thing, and that is that this horizontal line, and for this student it's more like a vertical line, can serve as an attentional anchor. This is an example of a student who correctly answers the question about a histogram. And what is interesting about this student, at first, after a bit looking around, you see this vertical pattern appearing, but also a kind of horizontal adjustment. And we come back to that later in our tasks, because we put it in our task as well. Another thing we learned is that the dot plot indeed helped our students. Before the dot plot intervention, so in the first 12 items, it was roughly like 20 to 30, 35% of the students who correctly answers the questions about histograms. After the dot plot intervention, that went up to like 50, 60%, something like that, depending on the specific item. But what we also learned is that the stack dot plot doesn't do that work, because then students think that every stack has only one value. Yes?
Yeah, you talk about the intervention. It seems to be like sort of more like an assessment.
Yeah, it's not an intervention like in the usual word that we use it, like an intervention in the classroom. But we did something with the students that helped them to better understand it. So in that way, it is a kind of intervention, yeah.
But it is what you sort of present now, is then they get these questions, a set of questions.
Yeah, and as we know, sometimes students learn from the assessment, and we think that here sometimes that happened, and we purposefully designed these questions for that reason, not to assess them how well they do on dot plots. That was not our aim. Okay? If you have other questions that you want to ask to clarify things, feel free to ask them, but if you have questions for the discussion, please postpone them to the discussion. Another thing is that some people say horizontal histograms will help students scaffold them in their understanding, and the results are kind of unclear on this. Also because we already had presented 23 items, so it's very hard to say what did what. So we will not throw it away immediately, but it's also not a clear result that we should put it in. So that's something for the discussion maybe. But the problem that we had with all these findings from the literature and from the eye tracking research, this is all already done. We have all these visualizations, except maybe for the histodot. We have these dynamic systems and Tinkerplots and all this neat software that can do the job for us. So, what now?
I'm sorry, but what do you mean it's already done?
Like
already supportive
software. There is already software that uses dot plots, and Tinkerplots that has sliders to divide your graph into kind of bins. So there is a lot of available already.
But it's not implemented widely in
But even when it was implemented, we only got like 50% of the students who understood the task or understood histograms, and I am interested as a teacher in the other half. Yeah? So I want to have all my classroom understand it, not only like you understand it, you not. I can't live with that. So we need a new kinds of tasks. And that's when the embodied tasks come in. So we got inspiration from psychologists, learning psychologists like Piaget, Vygotsky, Skam, Dionys, Brunner, and they all said something about that we should not only use symbolic or abstract mathematics, but also there should be something rooted in the action or in the body or in the doing or whatever. In the sensory motor system, that's the official word. So from the theory of embodied cognition, we learned that our thinking processes are based on our sensory motor systems, including touch and movement, and translated into statistics education. That means that we need physical, sensual experiments. And from this theory, we use that mathematical meaning can emerge from goal-oriented bodily movements, like sensory motor actions. So, I would like to invite Anna, who programmed a lot of tasks in the system, and also help me with, or co-design, it's more than helping, the task together. And we will explain some of the tasks that we designed. Yeah, she's going to switch, so that will take a little time. Yeah. So we first have a task with a context. The context, we would like to have feedback on it. It's with 10 students, and the heights of the students are given. And the aim of the task is to get students familiar with this horizontal scale where the height is, and this horizontal orientation. So what students need to do is take a case, like that one, and slid it to the right position. And we use the pre-knowledge, precognition of the students of the number scale so that they can use that to get a sense of what is going on in this dot plot. And the aim of this task, and also the other task, is to make students aware of what and how data are depicted in the graph. And from the findings in the literature, we thought that a dot plot would be a very good starting point. And I think our eye tracking research supports that idea. So what we do here in terms of data is raise students' awareness to every circle being a case. And what I said already, that the relevant variable is on the horizontal. The context, the height that you usually associate with a vertical, is now on the horizontal. And the embodied action is the horizontal hand movement in which students are coordinating their movement with their the orientation of the variable. Did I forget something?
No, I didn't.
Okay, good. And for the attentional anchor, what is relevant in this task is that the students are aware that the horizontal position of the cases count. So where we saw this student who correctly answered the histogram graph, he or she already replaced in a horizontal direction the vertical line to adjust to the right position. Okay. Yes.
Is each case connected to the one in the table?
Yes.
Light up or so, because I cannot see it from here.
They are connected, but they don't light up. That's a very good suggestion to do that. So we will note that. Thank you.
No, they are connected.
Yeah, but they're not like when you slide it that you see it in the table that it lights up, something like that.
See which one
Yeah.
No, just a second. The idea is that there are some already cases which are in the table. And depicted
you're right.
Here, and then there will be few more students. Presumably there will be school students in a class, and they would put themselves in the same scale. Or for the moment, we just added a few more, which they need also to place, which are not in the table yet.
Yeah.
So those who were placed from the beginning are in the table. The others are additional.
Yeah, you're right.
Oh, I thought something was checked in the end.
Yeah, you can check in the end whether they are in the correct position.
Yeah, okay.
Oh, because there's a number on
There
it.
is,
Yeah.
it's not seen really. It's not really
Yeah.
seen. Yeah, I'm sorry that it's so small. I actually could make it bigger, but it will take a bit of time. Do we need it?
And do we need to take time to make it bigger? No? Okay.
Yeah. The point is that on each ball there is a number written. So they know where to put it. Oops.
Yeah.
How did I? Oh. Okay. Sorry. That's good. Peter is not here. It's good aggressive. So it will take a second. You can next.
Okay, so the second task I will explain already while the system is going to restart. It's the same dot plot, but now we make a histogram overlay on this dot plot. And first students have to pull down sliders that are the borders of the bins, that are becoming the borders of the bins. And then after doing that, they pull up a strip. And they have to coordinate the height of this strip with the number of cases in each bin, in each bar.
Yeah, I will show it. Just a second.
Yeah,
I want to
she has to
put
do
this-
that, otherwise it won't work in the
No,
next
I
way.
think actually it will, but I don't want to check it now. So I better just
Yeah.
correct it.
So the embodied action here in the next task is the vertical movement to make students aware that this vertical movement is not the height context, but is the number of cases in a bar. And
This is what Monica just meant.
yeah,
This is one.
yeah, so you can't see the sliders on the screen. They are very light gray, so probably even the first row can't see them. But they are, maybe I can show them.
Ah, you can see the slide.
Yeah, here is the slider. You pull them down, and then you can,
After you have pulled it,
yeah, you
there
can,
is an interval.
yeah, there
that
is
you
a
can,
strip, and you can
rise.
rise it.
And there is grid so that you can see how many.
Yeah. And after that you have done this, there's a tick box, and you can check. Then there is a green histogram behind the histogram you made, so you can see whether what you did is what we expected. Yeah.
Yeah, so this is an opportunity to check what was wrong, but it can be also switched off so that you can just check that it's not correct or correct it.
Yeah. So we have those two options. So I already said in terms of embodied action, we have this vertical movement. And here is, in terms of data, this key concept, data, we want to raise students' awareness to the cases in a bar of a histogram. And that they contain different values in one bar, and not all values in the bar are the same. And yeah. About this task, yes?
Why is the frequency not as thick? Why is the unit not as thick as 1 point?
One bar. I think this is due to technical problems.
No, one
Yeah.
case.
Yeah,
That's a good question. We also had it.
yeah, it's a technical issue we didn't
Why? We
resolve
did
yet.
it.
Oh, I
Okay.
thought.
Yeah, it's actually quite an issue if it should be the same, or if it shouldn't be, because it's basically different type of a model, and it doesn't mean that because even if they would be the same height, it wouldn't lead that all circles would bump up one above another one, and we don't want just to see the student just to see, oh, pump, 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 it's built like this, but we need to count how many there are, and basically balls are points. They don't have any weight, they're
Yeah.
just points, so their size mean nothing, and to make it to be exactly one square doesn't necessarily lead to any additional comprehension, although I agree that it's debatable. We
Yeah.
spent quite some.
Mathematically, I understand, but when you want to have a more visual and embodied thing, I don't know if this is a fitting way.
Okay, but let's discuss about that
Yeah.
later on, because it's a very interesting point you raise here. Yeah.
Just a loose remark, but I think it would be nice if you had different colors for the different bins, so that you better see which
Okay, we'll think about that as well. Okay, so then we have this context that there are some ladies in the classroom who wear high heels. And when you wear high heels, your height goes up. So we have to adjust some of the cases in this histogram, in this dot plot, and also the histogram overlay that we designed here. So that's the third task. She's going to move some cases now, adjust them like 5 centimeters.
So in order to do it, I actually need to find out who is Maria from all them. And this requires coordinating this message dot plot with a table, since I need to read all right. Oh, okay, Maria is this one. And she actually is not 157, but 5 centimeters more. And it changes the need for chairs in this story. Okay, you want me to do all that? Yeah?
No, I don't think you really need all of that. And then after that, they have to adjust the heights of the histogram bars to the new situation. And this is, we made this task with in mind that we really need students to be aware of what the position of a case means in relation to the height of the bar. Yes?
If you take the heights of males and females, the distribution becomes bimodal, right?
Yeah.
It's a bimodal, yeah. Doesn't that mess with the student sets?
No, I don't think so. But this is also something I think is relevant, but for the discussion, if you don't mind. Okay?
It's not necessary in this age.
No. So then the last task, in this task I already said we have this vertical movement, and this is in line with the emergence, possible emergence of this attentional anchoring. And then we have the fourth task, in which we combine this all. So this idea of a horizontal position and a vertical movement. And what we have here is students can construct a histogram. We don't have a clear task for that yet. And then we ask them to find the mean. And finding a mean in a histogram is like finding the point where this graph is a kind of imbalance. So then you have to slit this slider to the right horizontal position, and at the same time find this vertical line for the mean.
Compare vertical height.
Yeah, compare the vertical heights of the bars. And we know that what we depicted here is not physically correct, but because if we make it physically correct, then it will go like that, and then all of a sudden like that, and there is only one exact point where it is in balance. But then the students don't get feedback when they are close, so that's why we make it physically a bit different, and that's also why we didn't, one of the reasons, there were all other technical reasons, why we didn't put the graph itself on a balance, because then you get even more in trouble with the physics. Okay? So we go back to the presentation. Thank you very much. Yeah. So these were the tasks. So what did we do? We had the literature on statistics education that informed us about conceptual difficulties, but also about the persistence of these difficulties. So we designed an eye tracking study, and both informed us for the embodied design. But it also led to the idea of attentional anchors, which is not new. I didn't invent that. We've seen it in other studies as well, which is an input for the embodied design, and the literature on embodied cognition. And those three together led to the design of these tasks. And although in our case, we were not very deliberately putting this idea of attentional anchors in our design, I think this is something that in the future we could look for in eye tracking studies and use it for designing on our tasks. So this is one of the added values, apart from that it clearly makes a difference between the eye movements and probably the thinking processes of students. But that is one of the added values of eye tracking study. I'm just almost finished. So if it's not a question that is really necessary now, just hold on for like 2 or 3 minutes. Because to summarize, our task is we think that these tasks will foster students when interpreting histograms, and in that way they also support the developing of a correct coordination between the statistical concept of data, distribution, and the graphical representation of these concepts. And if you want to know how difficult it is to disentangle the graphical representation and its sign, just think about the normal distribution. If you think about it, most of you probably think about a bell shape. But who of you thought about the S shape, the cumulative, or even a straight line on normal probability paper? So we cannot separate the graphs from the concepts. And with these tasks, we hope that not only students are able to interpret histograms very good, but also their teachers, the researchers, and the doctors. So this will foster research, and especially a more effective search for the treatment of pancreatic cancer. Thank you.